Good day, everyone. Today I'll be presenting my analysis of a real world computer engineering project using the EDP or Engineering Design Process. The project I chose is something I wish to design myself, a smart campus system that uses Internet of Things, in short IoT, to automatically monitor classroom attendance and room occupancy, while also optimizing energy use across the campus. In many schools, attendance checking still relies on manual methods, professors calling names or students signing sheets. This is time consuming, prone to errors, and easy to manipulate. At the same time, energy is often wasted because lights and air conditioning stay on even when rooms are empty. These issues might seem small individually, but across an entire campus, they cause huge losses in time, energy, and money. As computer engineers, our goal is to create a smart, efficient, and reliable system that can automate these processes, improving productivity and sustainability at the same time. But before designing anything, it's important to do proper research. I studied existing smart systems used in universities abroad and local. Found that many rely on technologies like RFID cards, Bluetooth sensors, Wi-Fi tracking, and motion detectors. However, some of these methods raise privacy concerns or are too expensive to even implement. Through this research, I learned that a balanced approach using RFID cards for attendance and motion plus CO2 sensors for occupancy detection can achieve both accuracy and cost efficiency without violating privacy. I also look into the hardware and software needed, such as ESP32 microcontrollers, PIR motion sensors, and Raspberry Pi gateways, as well as cloud services for storing and analyzing data. By combining these technologies, a smart, connected, and low-cost campus monitoring system becomes achievable. After gathering enough information, I brainstormed different approaches. One idea was to use facial recognition for attendance, but this could raise privacy and ethical issues. Another was to rely on smartphones via Bluetooth signals, but that would drain batteries and not all students might not even participate. The most practical solution that I found was RFID scanners for attendance logging and IoT sensors to monitor occupancy for energy optimization. This hybrid system balances privacy, cost, and accuracy. The reason I chose this because students will only need to swipe their ID cards upon entering the classroom, and sensors can automatically detect whether the room is occupied. If the room becomes empty, the system can automatically turn off lights and air conditioning, saving energy in real time. The data collected will be sent to a cloud database, allowing school administrators to track attendance and analyze room utilization efficiently. This prototype includes an ESP32 microcontroller, an RFID reader, a PIR motion sensor, and a CO2 sensor connected to a Raspberry Pi gateway. The microcontroller collects attendance and occupancy data, which is then transmitted wirelessly to the cloud using the MQTT protocol. The data can then be displayed on a dashboard for administrators and teachers to view. At this stage, I will build a small-scale prototype to test in one or two classrooms, and this will help determine how accurate the system is before expanding to the entire campus. Next comes testing. I will test the system's accuracy, speed, and reliability. For example, I would compare the RFID attendance results with manual attendance to measure accuracy. I would also test if the sensors correctly detect and when a room is empty and whether lights and air conditioning respond accordingly. If the system shows at least 95% accuracy and significantly reduces energy usage, it can be considered a success. Feedback from students and teachers would also be collected to check if the system is easy to use and not disruptive. Though no design is perfect the first time, after testing, we might find areas for improvement. For instance, if students forget to swipe their cards, we could add a small reminder system or integrate the RFID reader with a mobile notification. If the motion sensor reacts too slowly, we could adjust its sensitivity or add another sensor type for better detection. The key here is iteration, improving the system step by step until it works efficiently, securely, and reliably. After it's finally finished, the project is working properly. The results must be communicated clearly. This includes creating reports and presentations showing how much time and energy were saved, how accurate the attendance tracking is, and how students and teachers benefited. The system could then be introduced to other departments or even other schools, demonstrating how computer engineering innovations can make campuses smarter and more sustainable. Through this project, We learned that the engineering design process is more than just a series of steps. It's a mindset. By defining a real problem, researching carefully, brainstorming creatively, testing truly, and improving continuously, we can create meaningful solutions that directly help our communities. In this case, using ADP allows us to solve two common school problems, manual attendance and energy waste, with one integrated solution. It also shows how computer engineering can bridge the gap between technology and sustainability, helping not just schools, but society as a whole.